People and businesses around the world now have another reason for them to adopt 3D printing, and this time, it's right at the very top of the rocket's trajectory. Earlier this year, NASA and SpaceX successfully completed the first human spaceflight on a commercial spaceship, SpaceX's Dragon capsule. And despite this being their first trip, several new components were being tested for the first time in real-world situations with genuine, living people. And guess what? 3D printing seemed to be the backbone of all these new components. Well, how efficient do you think 3D printing is? Welcome to SpaceX Net. Do you think the idea of 3D printing a whole rocket is probable? How efficient would it be? In today's video, we take a look at the announcement made by Elon Musk concerning SpaceX that it will be the first time to build a 3D printed spacecraft. But first, before we go on with today's video, a sub to the channel would be very much appreciated. Comment, share the video, and don't forget to leave a thumbs up for the video. So, let's get into it. Some time back, the bizarre spacesuits, for example, had elicited both confused and unfavorable reactions from the fashion community. But let's take a closer look at the helmet of this spacesuit. It is just as complex as a costume, but it may go unnoticed because everyone's attention is focused on the outfit itself. It was announced in a press release from NASA that the helmet was specially manufactured using 3D printing technology, and that it incorporates integrated valves, mechanisms for visor retraction and locking, and microphones inside its design. Creating a sophisticated framework that simplifies operational usage and increases component quality while ignoring geometric difficulties is how 3D printing should be done right. The importance of these concerns decreases if 3D printing is adopted, but they become critical if traditional manufacturing is applied. Without this sophisticated design, this helmet would have had to be constructed from a number of distinct components, each of which would have had to be created and tested separately before being assembled and tested once again. In addition, there would be a potential for failure at each of the joints. Joints not only increase the likelihood of failure, but they also necessitate the addition of additional weight and material in order to keep the components together. What's more, each and every item is likely to be accompanied by its own audit trail, as well as for instructions for use, assembly, disassembly, and repair if applicable. But when the whole structure is 3D printed as a single component, the majority of these challenges and efforts are removed. It is at the heart of additive manufacturing processes, both in prototype and production, to make something better since design limits have been abolished. While the appearance of these helmets is undoubtedly interesting, there's a lot more going on here than meets the eye. It was only a small part of the hundreds of components that enabled SpaceX to accomplish the unthinkable: build a spaceship in record speed at a fraction of the cost of established competitors. For the vehicle and all of its supporting components, SpaceX is likely to have used sophisticated manufacturing and design processes comparable to those used by Boeing and Lockheed Martin, including extensive use of 3D printing, which, we understand, was also used to manufacture their metal rocket engines. In the next several years, commercial rocket firm SpaceX plans to carry humans into space using a cutting-edge process known as 3D printing. California-based SpaceX was using 3D printing to create emergency escape rockets for its next manned Dragon spacecraft, which was scheduled to launch in 2021. The competition is fierce for commercial manned spacecraft to transport passengers to and from the International Space Station. The first 3D printed component was successfully carried into space earlier this year by SpaceX. On January 6, SpaceX's Falcon 9 rocket launched with a commercial Thaicom 6 telecommunications satellite on board. The rocket mains engine oxidizer valve is the object in question in regards to 3D printing. For the first time ever, a 3D printed part flew in SpaceX's Falcon 9 rocket, with the valve proving to be dependable in harsh conditions such as cryogenic temperatures and high-pressure liquid oxygen, according to a statement from the company. Recent months have seen a lot of buzz around the possibility of 3D printing in outer space. An investigation of using 3D components to build lunar bases has been conducted by the European Space Agency, and a 3D printer produced in California is expected to be sent into orbit by NASA in late 2022. However, space manufacturing is still in its infancy, according to a recent National Research Council assessment, and the material science underpinning it is still little understood. SpaceX has been exploring and developing this rapidly expanding technology for the last 3 years, with a concentrate on its use on the Dragon spacecraft. Experiments with a 3D printed Super Draco engine chamber intended for use in the escape mechanism were carried out, and if you compare printing the chamber with typical manufacturing, the lead time from idea to first hot fire was little over 3 months. Using a 3D valve in the Falcon 9's engine will also be easier to produce. 3D printing has been thoroughly tested and is now approved for use on commercial planes alongside conventional materials. Testing on SpaceX's Super Draco rocket engine, which will be used to boost the Dragon spaceship's performance, has been completed successfully. Draco engines, now used to maintain inclination of the Dragon in orbit around the Sun, will be replaced by Super Draco engines, which will allow the spacecraft to execute a powered landing on Earth and other planets by replacing the Draco engines. Using a laser to create complicated metal structures out of metal powders one layer at a time, DMLS was utilized to build the Super Draco's combustion chamber, which is unique in the industry. Inconel, a nickel-chromium alloy with remarkable strength and endurance, is utilized to manufacture the combustion chamber, which is also used in the Merlin engine of the Falcon 9. SpaceX believes that they can build engine parts that are both long-lasting and high-performing using 3D printing at a fraction of the cost and time associated with the typical manufacturing techniques. Innovators like SpaceX are pushing the envelope of what is possible in the next 21st century by using additive manufacturing to create rockets that outperform every previous spacecraft in terms of efficiency, dependability, and robustness. It is possible for the Super Draco to restart a number of times due to the sparks igniting upon touch, with a response time of 100 milliseconds from ignition to full throttle. It's also designed for aggressive throttling. A total of 16,400 pounds of thrust may be generated by the Super Draco engine, which is 200 times more powerful than the Draco. The Super Draco's principal role is to maintain the Dragon capsule's altitude, both in orbit and on its return mission. When the vessel is launched, it serves as a method of escape. Instead of a rocket-powered tower that was utilized in the 1960s and 1970s, the Dragon's future generation will employ a rocket-powered tower to transfer the capsule in the event of a launch disaster. In contrast to the towers, which were only utilized during the first few minutes of the flight and then shut off, the Super Draco may be employed at any moment throughout the launch, from the pad to orbit. The actual thrust provided by the 8 engines working for 5 seconds each is enough to lift the capsule away from the launch vehicle. Super Draco's strength and control allow the Dragon to return to its spaceport and land with the accuracy of a helicopter, just like the Falcon 9 rocket. It's possible that SpaceX may employ the Super Draco engine in its Red Dragon Mars lander, an unmanned version of the Dragon that will land on Mars and conduct research on the planet's geography. According to the firm, test firings were conducted at SpaceX's McGregor, Texas rocket development facility last month that involved extended firings, many restarts, and working in challenging conditions. As part of NASA's Commercial Crew Integrated Capabilities program, the Super Draco will fly for the first time later this year and conduct a pad abort test. The cumulative impact on this industry may be substantial based on current estimates. There are a number of well-known rocket firms in different countries, all of which are now functioning with vehicles that seem to be outdated in comparison to their competitors. Perhaps they are still functional, but in the face of SpaceX's substantially less expensive alternative, they are no longer relevant. These companies will be forced to rethink their whole operation, including project management, supply networks, manufacturing processes, and most critically, equipment design, in the not-too-distant future. They'll have to catch up to SpaceX by developing similar low-cost orbital vehicles, or they'll be forced to close their doors in the near future. They will almost definitely adopt some of SpaceX's industry-leading methods in order to catch up. These professions will almost certainly see a significant increase in the use of 3D printing technology in the near future. The possibility of a similar scenario arising in other industries, where one side leverages cutting-edge technologies such as 3D printing to push the limit, is not improbable to occur. Evidently, this industry will change fast, and the shift will demand the use of a significant number of 3D printers and 3D designers who are knowledgeable of DFAM, which translates to design for additive manufacturing. And that's all for today's video. Thanks for watching. Did you like the video? Do you think that the adoption of 3G would revolutionize industries? Comment below, let's engage. Also, if you're interested in more videos like this, make sure you like this video, share and subscribe to our channel. Don't forget to turn on the notification bell for more amazing videos. Goodbye and see you in the next video.